Again, it's a red stick.
What is going on, guys? Welcome back to the C++ tutorial series. In today's video we're going to talk about operators in C++, so let's get right into it. Alright, so we're going to start out with the first category of operators here, which are the so-called arithmetic operators. And operators, generally speaking, are just tools, simple tools that allow us to perform operations onto values, onto objects, onto variables, and do something with them. For example, we have arithmetic operators that are mainly used for calculations, arithmetic calculations. Then you have stuff like comparison operators and stuff like assignment operators and so on. We're going to start out with the arithmetic operators first because they are very simple. They are just the basic mathematical operations. So we have arithmetic operators, and these are just essentially addition, subtraction, multiplication, division, and the modulus operator that we're going to talk about in a second. So let's say we have two variables here, int a equals 10 and b equals 20. What we want to do is we want to go ahead and print the sum of those. So what we do is we say std cout a plus b, and then std end line. So this is a basic addition. This is just a plus b, 10 plus 20. Of course, we can also go ahead and do one more. So we can say a plus b plus 70, for example. So in this case, we would get 100 because we have 10 plus 20, which is 30, and then plus 70 is 100. And now we can go ahead and compile and run this here. And you can see that 100 is the result here. Very simple. We also can do the same thing with subtraction. And if we do that, in this case, we would get 10 minus 20, which is negative 10, plus 70 would be 60 in the end. And we can do the same thing, of course, with multiplication and division and so on. So in this case, we would say 10 times 20, which is 200, and then we would divide by 70. Maybe let's divide by 40 and get 5 as a result here. So as you can see, we can just combine these arithmetic operators here. So I think division, multiplication, subtraction, and addition are pretty self-explanatory. What's maybe not that self-explanatory is the modulus operator. It basically just gives you the remainder of a division. So let's say we have a number like, I don't know, 7, or let's say 10. If we divide 10 by 2, what we get is 5 and a 0 as a remainder, if we're focusing on integers, of course. So because we're not going to, we're not calculating the decimal places, we're just calculating the integer result and then the remainder of the division. So in this case, it would be 0, so we can go ahead and say a modulo 2, or actually a modulo b, which is 2. And if we run that, you can see that the result will be 0 because 10 divided by 2, or 10 is divisible by 2, and therefore we don't get a remainder. If we go ahead and say b equals 3, we would get 10 divided by 3, and this would be 9, and 1 is a remainder. So in this case, if we go ahead and compile and run, you will see that we get 1. And of course, if I go ahead and do something else like 4, we would get 8 and 2 as a remainder. So actually, let's just delete that here and say F6. And you can see we get 2 as a remainder. So this is how the modulo operation or the modulus operator works, just calculating the remainder of a division here. Alright, so next let's talk about the assignment operators, and you already know the basic assignment operator. It's used to assign the value on the right to the object or variable on the left. So whenever we say int a equals 20, this equals here is the assignment operator. It's the most basic assignment operator, just takes the value on the right and assigns it to the placeholder on the left. Very simple, but this is not the only assignment operator that there is. And we can go ahead and combine the arithmetic operators that we already know with the assignment operator. So let's say we have this variable here and it has the value 20, and now we want to increase this value by 20 or by 10. Let's say we want to increase it by 10. Now, one way to do this is to just go ahead and say a equals a plus 10, because then what we do is we say, okay, get the value of a, the current value of a, add 10 to it, and then store this into this left variable here. And of course, it's going to be increased by 10, so the result is 30. And we can go ahead and print that by just saying cout a std end line. And if we do that, we're going to see that we have 30 as a result here. But this is not the only way to do it. We can also go ahead and use a specific operator for that, and this is the plus equal operator. So we have this operator right here, and this does the exact same thing. So it's just another way, a more compact way of writing the same thing. It's essentially just increasing the value of a by 10 and storing it into it. So we're not just calculating a plus 10, we're also saving the result into a as a result. So if we run this, we're going to get 30 as well. And this does not only work with addition, you can also do that with subtraction, you can do that with multiplication. So in this case, you would get a times 10 and save the result into a. So in this case, it would be 200. Oh, I clicked the wrong thing. There you go, 200 here. And you can do the same thing with division and even with the modulus operator. So in this case, if you go with the modulus operator, you would get 0 because 20 is divisible by 10, and therefore we have a 0 as a remainder. Also, this is not just limited to arithmetic operators. There are also other operators that can be used for this. There is a category called the bitwise operators that we're going to mention at the end of this video or later on in this video. But we're not going to learn about them in detail because they're not so important. We're going to talk about that. But you can also combine those bitwise operators with the assignment operator. So instead of using, let's say, one bitwise operator is this one here, this symbol here, what you can do is you can also use it like that to store the result of the bitwise operation into a. That we're going to talk about later, so don't be confused about that symbol here, that operator that you don't know yet. But essentially, you can use the assignment operator in combination with other operators to save the result of the operation into the variable. Now we also have two other operators that I would consider to be assignment operators because they're very similar to the combination of the basic assignment operator and the arithmetic operators, and those are increment and decrement. And these two operators are something that you will not find in Python, so if you're only used to Python, you probably don't know about them. And they're written like this. Let's say we have an integer a and a equals 10. Increment would be something like a plus plus. And this means essentially this is the same thing as saying a plus equals 1, which is the same thing as saying a equals a plus 1. So all these three commands here are doing the same thing. The difference here is though that we use a plus plus, first of all, because it's a more simple way to just increase the variable by 1 or the value by 1. But it's also used whenever you wanna return the value. So a plus plus is one way to do an increment, but you also have plus plus a. And the difference between that is that if you say a plus plus and you feed this into a C out, for example, or actually before I explain it, let's just do it. Let's say we have std C out a plus plus, and then we say std end line. What you will get here is you will print a plus plus, or you will print the value of a first because a is fed into C++, and then it's going to be increased. Whereas if you say plus plus a, you're going to first increase the value and then return it to the function or feed it into the function. So let's just go ahead and run this, and you're going to see that we have 10 here because first we print or we output a and then we increase it by 1. And if you go ahead and do the same thing here afterwards without the plus plus here, you're going to see that a is in fact or was in fact increased by 1. We can go ahead and do that. But it's not printed the first time because the increment happens after the printing. Whereas if I say plus plus a, it's going to first increment the value and then print it. So we can go ahead and actually let's go ahead and press F6 again. There you go. You can see it's immediately printed as 11 because we first increase it and then output a. And this also goes for the decrement operators. So we can do the same thing with minus minus. If we do it before the a, so if we say minus minus a, we're going to get 9 as the first print because it's first decreased. It's first we subtract 1 and then we print a, or the result of that variable, the content of that variable. And if we say a minus minus, it's going to first print a as it is and then decrease it by 1, as you can see in the console results here. All right, so another category that we have are the so-called comparison operators or relational operators. And as the name already says, they're used for comparisons, but they're especially important when we come to decision making, when we get to conditions, if statements, but also when we get to loops. So those operators are going to be very important when we make the code a little bit more conditional. So not just do this, do this, do this, but do this if something is true. We're going to use a lot of those comparison operators in if statements, in for loops, and while loops, and so when we get to them. But for now, there are essentially, I don't know how many there are, I think 6 comparison operators. The most basic one is the equal operator. So it's not one equal sign because that is associated with assignment. We use two equal signs to ask is something equal to something else. We use an exclamation mark and an equal sign to say is something not equal to something. And then we have the basic stuff like less than, greater than, less than or equal to, or greater than or equal to. So those are the comparison operators here, and all of those return a Boolean result. So when we have one value here on the left, a for example, and another value here on the right, the result of this operation here is not another number, it's not a string or something, it's a Boolean. So it's either 0 or 1, false or true, no or yes. So when we say a equals b, this is a statement, and the compiler or the computer is going to tell us that this is the case or this is not the case. So 0 would mean no, this is not a true statement, and 1 would mean yes, this is a true statement. So let's say we have int a equals 10 and b equals 20, and then we're going to std out the result of a less than b. This is a comparison, and the result of this comparison is obviously 1, as you can see, because 1 means true, and this is obviously a true statement. 10 is less than 20. We can do the same thing with greater than, and you're going to see that we're going to get a 0 here. So if we run this here, we're going to get 0 as a result. And if I go ahead and say a equals 20 and b equals 20, I'm also going to get 0 for the less than operator. But if I go ahead and ask, is a equal to b, I'm going to get 1 because they have the same value. And of course, I can also go ahead and do the not equal thing. So let's say I'm saying b is 30 and a is 20. I can say, okay, a is not equal to b. Is this true or not? Yes, it's true. As you can see here, we have a 1. It's true. And of course, we can say is a less than or equal to b. So in this case, it's less than b. So less or equal to is true because it's not equal to b, but it's still less than b, so it's true. But we can also set a to 30, for example, and it would still be true because the comparison is of course true. So this is how comparison operators basically work. They tell us if something is true or not, and this not only works for integers or numbers in general. This also works for objects and strings and so on. If you implement the right response to the operator, of course, but that is something for another video, so it's a little bit more advanced. But essentially, you can just use these operators to compare certain values, certain variables, certain objects, and then based on that comparison, based on that Boolean result, you can do certain things with if statements and loops that we're going to learn about later on. Now, one more thing that we can do with comparison operators is we can combine them into more complex, more sophisticated comparisons. And in order to combine comparisons, we need to use logical operators. So let's say, for example, we have a number a again equals 10 and b equals 20 as always. And then we want to say, okay, is a less than 20 but still greater than 5? In this case, it's true. So what we want to know is we want to know if this value here is less than this value, but still this value has to be greater than 5. So what we can do is we can say std out, and we would say, okay, a is less than b, but we also want a to be larger than 5, greater than 5. So in order to combine both of those statements here into one big comparison, to one statement, we're going to use logical operators. And here we can either use the and, we can use the or, and we can use the not, whereas the not is not applied to two sides, so we cannot say left, not right, but we essentially use the not on one statement. So if this one statement is true, it's going to be false, and if it's false, it's going to be true. But in this case, we need the and logical operator, so we use two and symbols here. We're not using one because one and symbol means something else in C++. First of all, it's used for pointers, but if you're not using it on variables, it's also used for the bitwise AND operation that we're going to talk about in a second. But this is essentially how you combine two Boolean values. So you say this here needs to be true and this here needs to be true. If one of them is false, the whole thing is false. So in this case, we can go ahead and say std end line and print this. We have a problem here. Oh, of course, this whole thing needs to be put into parentheses because otherwise we get an error, a compiling error. And as you can see, we get a wonderful result because A is less than B, 10 is less than 20, and 10 is also larger than 5, so greater than 5. In this case, both sub comparisons are true, and therefore, since we combine them with the and, both are true, so the whole thing is true. Now, if I say, okay, A needs to be less than B, but A also needs to be larger than 15, we have the left side being true because A, 10, is less than 20, but A, 10, is not greater than 15. So one part of the whole thing is wrong or false, and therefore the whole thing is going to be false. As you can see, when we run this, you can see that we get 0 as a result because the right thing, the right sub-statement, the right sub-comparison is not returning true. And this operator here, this and operator here, demands that everything, both sides, have to be true. And of course, we can go ahead and substitute it now with a or. This is, I don't know what this operator here is called, to be honest. But two of those operators here are considered the OR statement, the OR logical operation, which means that one of them has to be true, both can be true, but at least one of them has to be true. Okay, so if both are wrong, the whole thing is going to be wrong or false. But if one of them is true, that's enough. So even if that's not true, but that is true, or the other way around, it's totally fine and the whole thing returns true. So this is the OR operator. It's not exclusively OR, so it's not XOR, it's not either one or the other, it's at least one of them. Both of them is also fine. So this is the difference between an XOR operation. And here you can see we get 1 as the result. This is the basic OR operator. Of course, if I say, okay, it has to be larger than B and also larger than 25, for example, it's going to give us 0 because neither one of those sides is true. And then finally, we also have a not operator. Essentially, if we have something like A is less than B, we can add an exclamation mark before that whole statement here. And this means that whatever we get here as a result, negate it. If it's true, make it false. If it's false, make it true. And then we get the result. So in this case, A is less than B. This would return true, which is 1. But by applying this not operator here, we would get 0, so false. And you can see that we get 0. And of course, if I swap this here, we're going to get 1. Because it's false, and then it's true. And we can, of course, combine all these queries here. We can say not this and something else. And then we can use the whole statement here and make it or something else and so on. We can combine all these comparisons with logical operators to make a big whole statement about what has to be true in order for this whole thing to be true. So we can combine them using logical operators and build all kinds of different logical statements and structures here. All right, so last but not least, we're going to mention bitwise operators, but we're only going to mention them here for the sake of completeness. If you want to learn about bitwise operators, I recommend you to use Google to just type in bitwise operators C++. I'm not going to teach them here in this tutorial series because I think that it would not give you a lot of value. I've never used bitwise operators in my life, in my programming life, unless I was doing some coding challenges. So whenever I did something in HackerRank or Code Wars, maybe I needed bitwise operators 1 or 2 times there for some creative solution to solve some problem because there were artificial constraints on what I'm allowed to do. But I've never used bitwise operators in a project, and I don't think that you're going to need them anytime soon, unless you know you're programming in assembly or something. And if you need them, if you really think that you need bitwise operators, just go ahead and Google them. It's not too hard to learn them, but I don't think that I want to make this video even longer just to teach you bitwise operators. However, I'm going to tell you what they basically do, and they are just performing binary operations, bitwise operations. So let's say we have a number here like 15. 15 is a decimal number, and we can represent it in binary digits based on powers of 2. I'm not going to go into too much detail here, but essentially the number 15 looks something like that. Whereas the number, I don't know, 12 looks something like, let me think about it. We have 8, then 4, and then 0, 0. Yes. So those are the two numbers, 15 and 12 in binary representation. And what bitwise operators do is they apply certain logical operations onto the individual bits. So the AND operator, the AND bitwise operator would be something like that. And what it does is it goes through all the positions and combines them. So it says 0 and 1. Okay, that's 0. 0 and 1. Okay, that's 0. 1 and 1. That's 1. 1 and 1, that's 1. So the result would be 1, 1, 0, 0. Actually, it would just be 12 again. But this doesn't have to be the case. So let's say, for example, we have something like that. Or actually, in this case, it would be the same. But let's say we have something like that. This would result in 1, 0, 0, 0. So another number. So again, I'm not going to talk about the individual bitwise operators, but that's what they essentially do. They perform different logical bitwise operations here onto the individual bits. And this can be useful in some scenarios, but for our purposes, it's not something that we need. Alright, so that's it for today's video. I hope you enjoyed it. I hope you all learned something. If so, let me know by hitting the like button and leaving a comment in the comment section down below. Also, make sure you subscribe to this channel in order to see more future videos for free, and click that notification bell to not miss a single future video. Other than that, thank you very much for watching. See you in the next video, and bye.